Namaste class, welcome again. Now let us see a few more problems. Here we have to minimize z is equals to x plus 2y subjected to condition 2x plus y greater than or equal to 3 and x plus 2y greater than or equal to 6. So we first plot these two in equations. One is 2x plus y greater than or equal to 3. Now to plot this, we first write equation 2x plus y is equals to 3. Find its two solutions. So x is equals to now x and y. So if I take x is equals to 0, I get y is equals to 3. Now I take y is equals to, let us say, y is equals to 1. Now when I take y is equals to 1, I will get x is equals to 1. Second inequation is x plus 2y is greater than or equal to 6. So here x plus 2y is equal to 6 is my inequation. My equation. Here x and y, when I take x as 0, I get y as 3. When I take y as 0, I will get x as 6. So here I will plot these 2 points. For that, let us first draw x-axis, y-axis. Now this is our x-axis, y-axis. Now on this 0, 3, so along x is 0, along y 3. So suppose here we have that point 0, 3. Next point is 1, 1. So along x1, along y1. So it may be somewhere here. This point is 1, 1. Now I will join these 2 points. So let us join. So I will get a line. It will go something like this. And next equation is, so first write this equation. It is 2x plus y equal to 3. Next equation we have x plus 2y equal to 6. For that we have point 0, 3. So this is 0, 3. Then we have 6, 0. So here we have 6, 0. So now I have second line going like this. Now these two equations, if we see the common area, both these equations are like they are greater than 3 and greater than 6. So means origin should not be in the region. So I will see in outward direction like this, and in this I will get one unbounded region. So this region which I am showing with shading is our feasible region, unbounded feasible region. This area is our solution. Now corner point, if we talk about corner point, we have 2 corner point. One is 0, 3 A and other is say B, and value of this corner point is 6, 0. So here I will draw one column or one table in which I have a corner point. I have value of z. Now the equation of z is equals to x plus 2y. I will find the value of z at point A, which is 0, 3 and B, which is 6, 0. Now at 0, 3 I will get the value of z as 2 into 3, which is 6, and here at point B I will get z is equals to 6. So at 2 point at A and B I am getting value of z as 6. So z is equals to 6 we can consider as the minimum value. Now we will see the graph of equation 2x x plus 2y less than or equal to 6, because we have to find the minimum value, and this is unbounded region. So for unbounded region I have to check the solution for any equation. So I will say that now consider, or I will say that as feasible region is unbounded, consider in equation z is x plus 2y, consider in equation x plus 2y less than or equal to 6. So x plus 2y, here we have greater than or equal to 6, x plus 2y, here x plus 2y is greater than 6. We have to minimize x plus 2y only. Okay, so x plus 2y is equals to 6. We will plot x plus 2y is equals to 6. This line is x plus 2y this line is x plus 2y is equals to 6, and when we say less than or equal to 6, so then we have to see this side. Now there is no point common in the feasible region and this line, so I will say that, so as no point is common between x plus 2y less than or equal to 6 and feasible region, we will say that minimum value of z is at what point? So minimum value of z is 6 at point A and B. So z is minimum z, I will say z is minimum at all point between A and B. So z is minimum at all point between A and B. So when you get the same minimum or same maximum value at 2 points, then it will be possible at all the points joining those 2 points. So here we have minimum value between point A and B. At all the points we get the minimum value of z. Now here again we have a problem of minimization. So minimize and maximize. So that means minimum and maximum both values we have to find out. Z is given x plus 10y and subjected to inequations given x plus 2y less than or equal to 120, x plus y greater than or equal to 60 and x minus 2y greater than or equal to 0. So now we have 3 inequations. So let us consider all 3 inequations. First we have x plus 2y less than or equal to 120. So we consider x plus 2y equal to 120 and find out 2 solutions for this. So when I take x0 I get y as 60, when I take y0 I get x as 120. Now second equation I have x plus y greater than or equal to 60. So x and y, when I take x as 0, I get y 60. When I take y as 0, I will get x as 60. And third, we have x minus 2y is greater than or equal to 0. So here again x and y. So when I take x as 60, okay, so for this in equation we have to write equation also. So for these two in equations, let us move them slightly up. Here we will say x plus y equal to 60 and here x minus 2y equal to 0. So when I take x as say 120, I will get y as 60. Okay. When I take x as 0, I get y also 0. So now I will plot all these 3 points. So let us draw the graph. Okay. So first 0, 60. So better let us consider this point as 60 and this point as 120 on both the axes. Here it is 60 and 120. So first 0, 60. So this point. 120, 0, this point. So I will join these 2 points. It will go like this. Then I will take, so let us name this equation. It is x plus 2y is equals to 120. X plus 2y is equals to 120. Now second is x plus y equal to 60. So for that we have 0, 60 and 60, 0. So this point. Here it is less than 120, so I will see towards origin. Now I will draw these 2 points. I will join these 2 points. It will go something like this. And here also it is greater than 60. So that means I have to see on this side. So this will give me feasible region. So inside of this equation and outside of this equation. Now third is 0, 0 and 120, 60. So 120, 60, I have point somewhere here. 0, 0 is somewhere here. So I join these 2 lines. It will go like this. So suppose this point is somewhere here. Okay. So I will say that yes, 120, 60 is here. Now x minus 2y is equal to 0. Now it is passing through origin. So I cannot take origin to check this. Let us take this point 60, 0. So 60 minus 0. 60 minus 0 is greater than 0. That means this area, downside area, is our feasible region. So now I have 1 point, 2 point, 3 point and 4 point, and my area, required area which I have to find is this area. Means this is the feasible region. Okay, shaded region is the feasible region. I have here point A, point B, point C and point D. Now the coordinate of point A and coordinate of point D can be solved by solving this equation. This is x minus 2y is equals to 0, and this equation what we have discussed is x plus y equal to 60. So solution of, I will say solution of equation x plus y equal to 60 and x minus 2y equal to 0. Solution of equation this gives coordinate of point A. Okay, so for this what we do, we subtract the second equation from first equation. So I have 3y is equals to 60, y equal to 20. So y is 20. Now y is 20, so x is equals to 4040. So the coordinate of point A is 40, 20. So therefore I will say therefore A is 40, 20. Now to get the coordinate of point D, I will solve x plus 2y is 120 and x minus 2y is 0. So to get coordinate of D, we solve x plus 2y is equals to 120 and x minus 2y is equals to 0. So therefore here we will add and we will get 2x is equals to 120. This implies x is equals to 60. So value of x is 60. We put value of x is 60, we get value of y as 30. So x is 60 and y is 30. So therefore point D is 60, 30. So we got the coordinate of A and D. A is 40, 20 and D is 60, 30. So I will find now the values of z at point A, B, C and D. So here we will draw a table where we have corner point and value of z. So z here we have 5x plus 10y. Z is equals to 5x plus 10y. Now corner point, I have point A which is 40, 20. Point B as 60, 0. Point C as 120, 0 and point D as 60, 40. And the value of z, 5x, so 5 into 40, 200 plus 20 into 10, 200, we get 400. Here the value of z is 5 into 60 is equals to 300. Here we have z is equals to 5 into 120 is equals to 600 and here we have z is equals to 5 into 60, so 6 5s are 30, that is 300 plus 10 into 40, so this is 400 is equals to 700. Now I have to find minimum and maximum value both. So here the minimum value which I am getting, what is happening? Okay, I understood. Okay, fine. So here 300 is minimum value. This is minimum value. And this 700 is maximum value. Now, as our feasible region is a bounded region, the minimum value which I got is the minimum value and the maximum value is the maximum value. So I will say that therefore Z is maximum at x is equals to 60, y is equals to 40, and maximum value of Z is 700. Also, Z is minimum at x is equals to 60 and y equal to 0, and Z minimum is equals to 300. So Z maximum is 700 and Z minimum is 300. Okay, so now in this problem we have seen both the cases that we have to find minimum value and maximum value. We have to minimize and we have to maximize. Again, this problem is of minimization and maximization. Minimize and maximize. This problem is of maximization. So this minimize and maximize, let us solve this problem also. Fine. Okay. So here we have one equation, x plus 2y greater than or equal to 100. So here we consider equation as x plus 2y is equals to 100. Its solution will be I will consider x as 0, it gives me y as 50, and I take y as 0, it gives me x as 100. The second inequation is 2x minus y is less than or equal to 0. So here its equation will be 2x minus y is 0. Here I will find xy. So when x is 0, I have y as 0, and when we take x as say 100, then or x I will take 50, that is better. I take x as 50, then y will be 100. And third equation is 2x plus y less than or equal to 200. Now here my equation is 2x plus y equal to 200. Now here x and y. When I take y as 0, I get x as 0. So when I take x as 0, I get y as 200, and when I take y as 0, I will get x as 100. Now I have to plot them on a graph paper. So let us draw the graph paper. So here this is graph. Here x plus 2y is equals to 100, so 0 comma 50. Now here I take this point as 50, this point as 100. Similarly here we have 50 and 100. So 0 comma 50. So along x-axis we have 0, along y-axis 50. So this point, along x-axis 100, and along y-axis 0. I will join these 2 points. This is my equation, x plus 2y is equals to 100. Now 2x minus y 0, so 0 comma 0 and 50 comma 100. So 50 comma 100 is this point. So I will join this 0 0, and so I will get a line like this. It will go like this. It will go something like this. Now where we have to see, let us see an equation. X plus 2y is greater than 100. That means I will see on this side away from origin. 2x minus y is 0. So for that, let us check this 50 comma 0. Now 50 comma 0, if I take x 50 and y 0, then 50 comma 0 does not satisfy. So I have to see above this line. So I will see on this side, and my third equation is 2x plus y is equals to 200. So here 0 comma 200. So 0 comma 200 maybe somewhere 0 comma 200. I will take 200 here. Zero comma 200 is this point, and 100 comma 0 is this point. So I will join these 2 points. It is something like this. So the common area, here our equation is 2x plus y less than 200. So I will see towards origin. So towards origin means on this side. Now the feasible region I will get is this shaded area. Now in this shaded region, I know the coordinate of this point. Let us take this point as A. This point we will say is A. This point say is B. This point is say C, and this point as D. So we have to find the coordinate of point C and D. Rest all we know. Let us write equations, respective equations. X plus 2y is equals to 100 we have written. Next equation which we plot is 2x minus y is 0. So this equation is 2x minus y is 0. And third equation which we plot is 2x plus y is 200. 2x plus y is equals to 200. Now I have to find the coordinate of point B, coordinate of point C and D, okay, before we proceed further. So I will say that to locate or to find coordinate of point B, we solve. Now B is to locate the coordinate of point C. Okay, B to already we know. To locate the coordinate of point C, we solve x plus 2y x plus 2y is equals to 100 and 2x minus y is equals to 0. Okay, so for this what we do, we multiply this equation by 2. So I will get 4x minus 2y is 0, and then I add this equation and this equation. So x plus 4x is 5x. I get 5x is equals to 100. This gives me value of x as 100 divided by 5 is equals to 20. So when x is 20, I will get the value of y. So value of y, 2x is y is equals to 2x, so I get y is equals to 40. So coordinate of point C is 20, 40. Okay, so this point is 20, 40. Now to find coordinate of B, so to find coordinate of point D, we solve. Now to locate coordinate of point D, we solve 2x plus y equal to 200, 2x plus y is equals to 200 and 2x minus y is equals to 0. So here we add, we get 4x is equals to 200. That gives me value of x as 50 and value of y as y is equals to 2x, so y is 100. So the coordinate of point D is 50, 100. So D is 50, 100. So we have now coordinate of A, B, C and D. So I will find the corner value of z at corner points. So here I will draw a table of corner point and here value of z. Now z is equals to, what is the equation of z? Z is x plus 2y. So value of z is x plus 2y. Corner points are A, B, C and D. Now coordinate of point A is 0, 200, coordinate of point B is 0, 50, coordinate of point C is 20, 40 and coordinate of point D is 50, 100. And the value of z, x plus 2y. So here 2y will give me value of z as 400. Here I will get value of z as 50 into 2 is 100. Here I will get value of z as 20 plus 40 into 2, 80, that is 100. And here I will get value of z as 50 plus 200, that is 250. So here we are getting the maximum value of z as 400 at point A and minimum value of z as 100 at 2.1 at B and C. So this is maximum value and this is minimum value. At 2 point we are getting minimum value. So therefore I will say that z max is 400 at A 0, 200 and z min is 100 on line, I will say that on segment BC. Instead of line we will say that on segment BC. So that is at each and every point between B and C, the value of z is minimum. Okay, so two more questions are there. We have to maximize minus x plus 2y, x greater than or equal to 3, x plus y greater than 5, x plus 2y greater than 6 and y is greater than 0. This one problem. Now you can try this problem. And one more problem. We have to maximize z is equals to x plus y. Condition is x minus y less than minus 1, minus x plus y less than 0, and x y greater than or equal to 0. So I recommend that you try these problems. They are also going to be simple as we have done all previous problems. So in this lecture we have understood how to solve linear programming problems. Okay, what we have to do here, we have to first plot all the n equations, then we have to locate the feasible region, then we have to check the value of z at the corner points. Now the corner point at which we get z value maximum, that will give me the maximum value of z at that corner point, and similarly I get the minimum value. Now when my feasible region is unbounded, okay, when it is not closed, then in that case minimum or maximum value, okay, is possible when the area, the region of an equation formed by objective function, formed by that maximize or minimize function, okay, with maximum or minimum value does not have any common point, then in that case we get the maximum or minimum value, otherwise maximum or minimum value is not possible. So in this lecture we have seen how to solve this maximization and minimization type of problems. Now in next lecture we will see few problems, okay, real life problems related with maximization and minimization. Yes, thank you for being with me in this lecture. Let us meet you in our next class. Thank you.